Hello everybody, this is Mrs. Snook with section 11.2, surface area of prisms and cylinders. Our objective today is to find the surface area of prisms and cylinders. Part 1 is prisms. First of all, a prism is a three-dimensional shape that has two congruent parallel faces called bases. So if you look in our picture here, we have a triangular prism, and the bases are the two triangles on the top and the bottom, and then the other faces are called the lateral faces. Those are the ones that go around the side. We also have a pentagonal prism, where the bases, top and bottom, are pentagons, and then the lateral areas are these rectangles going around the side. And we can have a rectangular prism, which I'm going to try to draw. So here's my base. I'm going to draw it like this.
I like how when we walk, we're charging with the spear.
And then these little dashed lines are showing the back sides. So that's a rectangular prism. Now, surface area means adding the area of all the surfaces of your prism together. So you're going to add the tops, the bottoms, the sides. And we have a pretty nifty, easy way of doing this, which is in Theorem 11.1. What you do is you take the lateral area, which are those rectangles, and then you add that to the area of your two bases. So this big B here means the bases. And for the prisms we're going to do, our lateral area is going to be the perimeter of the base. And then you just multiply that by the height, so that's going to give you the area of each of these rectangles all around the side. And then you just add the area of the bases. So let's go ahead and do an example. Our first one's going to be a triangular prism. And our equation is surface area equals lateral area plus twice the base. And our lateral area is just the perimeter times the height. So I'm just going to substitute that in. It's going to go right here. So surface area is perimeter times the height plus 2 times the base. And you are welcome to use that as a formula if you want. So that means that to solve this, I need the perimeter, I need the height, and I need the area of that triangular base. So first, let's get our perimeter. Well, the base, it turns out, is a right triangle. This side is 3, this side is 4. And I can use Pythagorean's theorem to get the third side here. So 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. 25 equals x squared, so x equals 5. So that means our perimeter equals 3 plus 4 plus 5. And let's see, 7 plus 5, that's 12. So I've got the perimeter. Next, height. The height is given as 6 centimeters, so I have the height. The last thing I need is the area of the base. That's a triangle. So if you remember, area of a triangle, in this case large B, is 1/2 little b times h. Now our base and height of a triangle are where we have a 90-degree angle. So 3 and 4 are the base and the height. So big B equals 1/2 3 times 4, which gives you 6. So now I have everything I need to plug into my formula. So my surface area is P times H, or 12 times 6, plus 2 times big B, or 2 times 6. So now punch that on your calculator. 12 times 6 plus 2 times 6, I get 84. Our units are centimeters, and area units are squared. So this is going to be centimeters squared. So that's our final answer. I'm going to highlight that for us. All right, another shape that you're going to be responsible for is the rectangular prism. Now in your book, it says to do this with a net. So you would actually draw each surface, but you don't have to do it that way. We're just going to use our formula. So surface area equals our lateral area plus 2 times the base. Lateral area is still the perimeter around the base times the height. So I'm still going to have perimeter times height plus 2b. So I still need to have the perimeter, the height, and the area of the base. So perimeter, well, I'm given that this is a rectangular base, so this is 4, that's 3. That makes this back side 4, and this side 3. So my perimeter is literally 3 plus 4 plus 3 plus 4. I get 14. The height we are given as 5. Area of the base. Well, I need the area of the rectangle. Here's my rectangle, 4 times 3. So my area is length times width, so 4 times 3. I get 12. So now I've got everything that I need. So my surface area is going to be perimeter, which was 14, times the height, which is 5, plus 2 times big B, which is 12. Punch that in my calculator. You get 14 times 5 plus 2 times 12. I get 94. Don't forget your units, centimeters squared. All right, next part is the cylinder. Now, a cylinder has 2 bases, which are circles, and a rectangle wrapped around the sides. So look at this picture here. We have a picture of a cylinder. Here's the rectangle that's wrapped around the side. I like to think of this as a soup can. Here's the wrapper from the soup can. It's like if you could take that wrapper off, if you peel that label off, you're going to get a rectangle. And then there's the top and the bottom of the can. Now these pictures are a net. You don't have to draw nets, but it does help to visualize what's going on with a cylinder. Another way to think of a cylinder is as a prism with a circular base. So we can do the same thing. We can do surface area is lateral area plus the area of the 2 bases. So here's our area of 2 circles. Lateral area is this rectangle, which means I can put those 2 together and I can say the surface area is going to be 2 pi RH, where R is the radius of that circle, H is how tall the cylinder is, plus 2 pi R squared. It's pretty much exactly like we were doing for the prisms, but now our base is circular. And that is shown to us in Theorem 11.2. Right here is the equation that we just wrote. So now let's find the surface area of a cylinder. This time I'm not giving you a picture. I just have a written description. The cylinder has a height of 9 centimeters and a radius of 10 centimeters. Let's see if I can draw this. So here's my radius, which is 10 centimeters, and my height is 9 centimeters. And I'm just going to plug into our formula. So surface area equals 2 pi RH plus 2 pi R squared. And we are asked to give the surface area of that cylinder in terms of pi. So what that means is when I do my calculation, I am not going to put pi in the calculator. I'm just going to leave pi written as it is, as the Greek letter pi, in my answer. So what do I need to solve this? Well, I need the radius and I need the height. And lucky for us, we were given the radius and the height. Our radius is 10 centimeters and our height is 9 centimeters. So I just have to plug in. So 2 pi, radius is 9, height is 10, plus 2 pi, radius is 10 squared. Oh, did I say that backwards? I did. So the radius is 10, the height is 9. Okay. 2 times 10 times 9 is 180 pi. Plus, get this, 10 squared is 100, times 2 is 200. I'm not even using a calculator. And then 180 plus 200 is 380 pi. And don't forget units, centimeters squared. All right, folks, that's it for this video on section 11.2. And as always, please remember that in Christ, there is joy and hope. Thank you.